equal and equals the whole. It just doesn't work that way. And so we talked about then the three castes that are making up that whole. In other words, that hive is much greater than the individual insects because they're all working in this crazy cooperative behavior that seems completely counter to evolution. So the first one we talked about were the workers. Again, the workers are the female caste that are sterile. So two big things to remember. The next group of a caste that we talked about are the queens, and the queens are, again, female, but she's fertile. The third group that we're going to talk about are the drones, and the drones are the males. Now, the drones are the ones that I would collect and let my children play with when they were younger because they don't have a stinger. So my children could kind of play with them, let them crawl around their hands and those kind of things, and I didn't have any fear about getting stung because they're males. They don't have stingers. The male honeybee is kind of an interesting critter. He's got on the top of his head, as I alluded to earlier, these enormous eyes compared to like the worker or the queen. I'm going to show you a face-on view in a few minutes. Here's a picture of a drone on the frame. I mean, he's just sort of a dumpy-looking critter, to be honest with you. I also thought he looks like a beer barrel because he's got this big round top and a big round. He just looks to me like a very disproportionate insect. And so when you start seeing drones in your hives, which you'll see during the summertime, they actually serve a genetic purpose. And that's it. They just serve for genes and gene transfer and gametes. In the story, that's all they're there for. And that boils down into sex. Here's a picture of a drone in flight. You notice these hugely bulbous eyes on the front. The drones are much like the queens and the workers. Their life cycle starts as an egg that goes then to a larvae, and then within that cell, the cell gets capped, and then he emerges. So his development is much like a worker, although his only job is to fertilize what are referred to as virgin queens. Whereas the workers, the females, 60,000 of them maybe in a hive, their job is to do everything from collecting nectar, to feeding the queen, to rearing the young, to making the wax, to, in some cases, becoming morticians. There's this little cool group of workers that become just morticians, carry out the dead, and become guard bees. The guys, their job is to have sex. That's it. Here's a picture of drone cells down at the very bottom. They have these really dome caps to the cells to accommodate this massive ocular capacity on their heads. I'm going to go into the life cycle, and again, we just touched on the caste, so you've heard the three castes before. Now we're going to talk about the life cycle because then those castes and the types of castes will kind of roll into that. So you're looking sort of more or less head-on at the three castes. Did everyone see that either on this one or on your take-home? So the queen is at the top. Notice that she has, well, she's not quite as, well, we use the word hairy as the worker down to the bottom left. Notice that, they still both have antennae, they've got mouth parts, they've got their eyes are virtually the same. The big difference is at the bottom left-hand side, the worker has, a large amount of hairs. Again, the reason is everyone find this one? Okay, good. The reason is the worker's job is to go forage, and part of foraging is collecting pollen, and to collect that pollen, they need these hairs to sort of accumulate that pollen. And so that's the worker. And then you can kind of compare both the worker and the queen to the drone in the bottom. Again, both I see some antennae, some mouth parts, but notice these huge eyes that wrap almost entirely around the drone's head. And again, that all has to do with reproduction. And it all rolls into honeybee intercourse. This is the topic that when I give talks in school, public schools and middle schools, I get lots of giggles and things because we're talking about how an insect procreates. What's kind of fascinating is when people sort of make these comparisons between how honeybees behave in nature and sort of how humans behave in nature, it gets quite kind of funny and lots of giggles. But I'll say this. The basic biology is fairly straightforward. So the drone bee, as I mentioned earlier, has this really large eye capacity, enormous compound eyes on its head. There are these areas out in the environment. We don't exactly know how these areas get chosen, but they're called drone congregation areas. The best analogy that I've come up with after lots of years of thinking about this is it's almost like the corner sports bar. forgive me, not to be too sexist, but these drone congregation areas exist out in the ecosystem. So out in the landscape, in the morning when the sun comes up and the hive starts to sort of more or less wake up, the drones are fed by the workers. And then they all leave and they go hang out in these drone congregation areas. And it's more or less drones from multiple hives. And again, we don't exactly know how these areas are chosen. We don't know how often they get used. They just happen to somehow get marked. And so all the drones, sort of from multiple hives, will all end up generally 15-ish to 20 feet-ish off the ground-ish, more or less. In other words, typically up in the air. 20-ish feet or so up in the air. Often it'll be a tree branch, it'll be some kind of structure. It could be at the corner of a building or a window that's up a couple of stories high. And these drone congregation areas are where the drones just hang out. So, as I mentioned earlier, on that second bullet point there, as I mentioned earlier, the hive can create a queen. And I don't want to go into those details just yet. Just know that the hive can create a queen. And when that queen hatches, she's called a virgin queen. If there are other queens that are in the hive, there's sort of this battle royale that happens because, as I mentioned, only one can survive. And so this virgin queen, after she sort of established herself as the matriarch of that hive, that virgin queen then flies off to go find this drone congregation area. This is some really interesting work. I'm going to show you pictures from some National Geo, but essentially, she's taking her mating flight. So this virgin queen flies to this drone congregation area where there are these thousands, it's quite large, of unrelated drones. And the queens will then, as they're flying, they're releasing these pheromones. And the drones pick up on those pheromones. Think of it like really strong perfume. And as she's flying, these drones pick up on that, and they start to fly and more or less chase her. And that's why they need these large eyes, because the intercourse happens in flight. And so you can imagine these two insects flying through the air. The drone then mates, and the queen will mate with several drones. 3, 4, generally less than 20. As we think of it, more in the order of 5 or so. Sometimes upwards of 10, this queen is mating, and that's where the mixing of genes happen within the honeybee's insect world. So during sort of the ejaculation phase, the male will then flip backwards, and the endophallus gets ripped out of his body, and he falls to the ground and dies. That's it. So that's literally his job, is to transfer genes from one generation to the next. The queen then returns. Now she's got multiple endophalli. She returns to the hive and is groomed, and that cascades some very fascinating social behaviors within the hive, sort of accepting that queen as a mated queen. She'll take the sperm that she has collected during this mating flight and store it in her spermatheca. There was a question, and I'm glad it was raised. How old can a queen live to be? Generally, in the wild, she can be 4, maybe 5 years old. And it's not so much that she dies, it's that she runs out of sperm. She leaves the hive, generally, unless she swarms or for some other reason leaves, generally she will spend her whole life in a hive. 5 years, 4 years. If you're keeping honeybees in a more or less beekeeping kind of style of thing where you're managing them, you might get 3 years out of your queen. The question about queens and breeding is really fascinating because some of the genetic traits that I mentioned earlier, gentle behavior, good production, ability to survive the winter, those are all genetic traits, and so beekeepers have almost kind of gotten these little breeding groups where they sort of trade. It's almost like horses, honestly, where you have queens and drones that are sort of being artificially bred together. So the queens that you're likely to end up with when you buy your packages, they've been artificially inseminated. They haven't sort of gone through this because the danger is if the queen goes out into the environment and mates with a more or less undesirable drone, you could end up with some kind of questionable genetics and then questionable traits. I think what kind of fascinated researchers is that when the Africanized strains of honeybees started making their way into the United States. The big question was, what happens when that Africanized strain starts to mix with the European strains? So, what's the genetic sort of outcome? What's that offspring? How are they going to behave? Which parent are they going to sort of take after? As it turns out, in most cases, the European behaviors, the more or less gentle nature, tends to win out over the more aggressive Africanized behaviors. But back to honeybee, and of course, top left-hand picture, this was taken from the National Geographic. They suspended a queen up in the air and were able, using still photography, to take some beautiful images. It's so extraordinarily rare to see this. As I mentioned, these drone congregation areas, we don't know where they are. We're only talking about a fairly small insect. But to actually see compilation happening. In their bottom right-hand picture, this is a picture of the endophallus that's left after the queen's returned back to the hive. This is the last one that's left. One of the questions that researchers for many, many, many years questioned is, well, what's the reasoning? How did the sex get determined? What makes the difference between the boys and the girls, between the males and the females? And we first thought it was a function of fertilization. And it was a fairly straightforward thought that if the egg had been fertilized, raise your hand if you'd even heard this. If it was a fertilized egg, it was a female. If the egg was not fertilized, then it was a male. That's the way I learned it in high school, to be honest with you. There was some later work that was able to point out in some of these very controlled environments where we weren't letting nature sort of take its course, that in some cases, we talk about fertilized eggs as being diploid, having two copies of the same gene, and we talk about the unfertilized egg, which classically is the male that we would see in nature being haploid, or having half of the number of genes. So the diploid males were observed in breeding studies, and so being diploid, the expectation was these would all be females, but as it turns out these were males. And so sex was clearly not a function of fertilization of chromosomes. There's a gene called the CSD gene, or the sex-determinant gene, that determines sex. Fertilized eggs that are heterozygous for CSD is the female. The homozygous for that is the lethal male. And so, again, this is one of those cases where researchers, by taking honeybees out of their natural environment, we were able to start seeing some of the more quirky traits, because in nature, if you had a homozygous male that would be lethal, would be dead, the workers would take this male out as it's developing. And it just wouldn't survive. I've kind of drawn you some complicated pictures of what a CSD gene. Read this on your own time. If you're interested in genetics, I can go into some more details on this. But just know that the sex of an insect, or the sex of this honeybee, has more to do with how many copies of this gene, and whether or not it's homozygous or heterozygous, than just being fertilized or unfertilized eggs. As I've noticed down here, that's the homozygous male who dies. And he dies in nature, and so you would never expect to see him in your hives. The life cycle, as I alluded to earlier, the job of the queen is to essentially lay fertilized eggs, to make workers. The life cycle of all of the three castes, the worker, the queen, and the drone, all start the same. They all start as an egg. I'm showing you a couple of pictures. There's some eggs. They're sitting in the bottom of a cell. Just kind of pointing them out here. The eggs then, I'm going to show you this image, and I'm going to turn all the lights off, because I'm going to come back to this in a few minutes. This is a picture of a frame. This is a picture of a frame. And if you're close enough in the front row, you can clearly see this. Hopefully in the back you can. This frame is made out of black plastic. And so at the very bottom of this black plastic are these tiny little white grains. They look almost like grains of rice, even half the size of a grain of rice. And these are eggs. They're very, very, very easy to see against black plastic. And so when we talk about equipment next, where I'm going to keep mentioning the word black plastic foundation, because that's one of the best things that I've found over the years for beginning beekeepers to sort of use as they're setting up their hive. Back to the point, the life cycle of all of the castes start as an egg. From there, the egg hatches. And much like you would think of butterflies and all the rest of the insects, they go through the same sort of stages, the instar stages. So it starts first with an egg. The egg hatches to a larvae. The larvae then grow up inside the cell. And you'll start to see these when you start keeping your bees. You'll take a frame out and you'll see these kind of white wormy looking things in the bottom. Kind of gooey looking stuff. Well, those are larvae. That kind of wormy looking thing, that's the larvae. The larvae then grow up and they get fatter and fatter and fatter. You can kind of see this, some larvae here, they're really filling up the cell. And that's the idea of these Wednesday workshops too, is to give you a chance to see this out in the apiary. So I can show you pictures and talk to you about it, but when you see it in real life, it's wonderful. So here's some larvae that are down in these cells. The larvae then sort of continue to grow and grow and grow, and they elongate, and they enter the pupa stage. And when they enter the pupa stage, they will kind of make a cocoon much like a caterpillar makes when it becomes a butterfly. Honeybees do it, but it's not quite like the same cocoon, but this entire life cycle is happening inside of a cell. And as I mentioned earlier, when the pupa, or when the larvae enters the pupa stage, the workers will then put a wax cap over the top of that cell. Now notice it's a little bit difficult to see, but these wax cappings are roughly kind of flat to the frame. Those are workers. Compared to the cappings that are over here on this side, these big dome shape, these are the drones, again for that massive head. And then this is kind of a long peanut looking shape. This is a queen. So again, the worker, the drone, and the queen, their life cycle is all the same. Egg, larvae, pupa. During that final pupation stage, much like, again, to use an analogy, the caterpillar butterfly model, this pupa now is going through the final stages of, well, metamorphosis. It's starting on the right-hand side. This is a cross-section of one of those frames with a young pupa over here, slightly older pupa over here. You can see that it's really started to adapt, start to look a lot like an adult. Again, just a cross-section to kind of show you those images. After the cells are capped, then the workers later emerge. So the workers will emerge, the queens emerge, and the drones emerge, after they've kind of finalized their pupa stage. A couple of quick things to note. The workers, again, when they emerge, their jobs are more or less pre-programmed based on their age. And starting as a nurse bee, and then later more or less as construction, and then a forager. The queens, as I mentioned earlier, they kind of have a little bit different role when they emerge. They will sort of seek out their competition and sort of fight to the death. The drones, on the other hand, when they emerge, life is pretty sweet because they just get fed until they get their heads ripped off. But that's for the fall lecture. The life cycle from egg to adult is, so workers are about 21 days, drones are about 24 days, so it takes a little bit longer to make a male, whereas queens are 16 days. Now this can vary by race, but these are generally more or less benchmarks for the Italian honeybee. I find this fascinating, as again, I mentioned earlier, the genetic makeup of a worker and a queen is identical. So how in the world can this queen go through her life stages so much faster than a worker? And it all boils down to the diet that she's fed. When she's in that larval stage, she is fed royal jelly, and she's fed a lot of it. Now I'll say this, the worker and the drone is also fed royal jelly, but it's a very, very, very small amount. That queen, when she's in that larval stage, is fed royal jelly, and that causes her time through her life cycle to just speed up tremendously. Yeah, some great pictures. Yeah.
Excuse me. You mentioned the queen mating, cruising past the sports bar, if you will. How many times does a queen mate? One?
Yeah, that's a great question. She mates once in her life. And so all the sperm that she gathers during that mating flight, she puts in something called a spermatheca. And that sperm is kept alive by that queen. And then as she's laying eggs, she'll choose one sperm to lay with that egg, and so that's a fertilized egg. That's it.
And that's used across, that's all it's used, obviously, across that 3 to 4 year
time frame. And when she runs out, she runs out. And oftentimes, when she starts running low in sperm, it's generally about the same time that she starts to decrease certain hormone productions, which trigger the workers to know that something's kind of not going right with this queen, and the workers will actually kill the queen and make a new one. We'll get to some more of that. That's the really fascinating part about this insect, and we'll get to some good questions. Any other questions?
Yeah, you showed some images of a hive where it looked to be a queen cell being developed.
Yeah.
do multiple queen cells develop within a hive, and how are you mitigated back to one queen?
Boy, that's a great question, and the answer is yes. So to the scenario in the back, let's say that the queen is starting to get old, and you'll see this in your own hives, probably around the 3rd year, maybe 4th year. If you see it your 1st year, call me. Generally around that 3rd or 4th year when the queen's starting to fail, she's run out of sperm, she's starting to get weak. Because again, she's laid 2,000 eggs a day, for Pete's sake, she's wearing out. Oftentimes what will happen is a worker, or the workers will select eggs that would have become workers, and they'll make a queen from that egg. And they'll generally make 4, 5, 6 queens all at the same time. And so the first queen that emerges, again, there can only be one. Her job is to run around the hive and try to find as many of her sisters that are being made into queens, and she stabs them. She will do everything she can to essentially poke this with more or less her ovipositor, as I understand it. And I'm not an expert on this. I think it's a fascinating topic. And or physically kind of fight to see who wins. But generally, there can be only one, and so there will only be one queen, and then we take that flight and go back to take the ownership of that hive. Yes. Hives. So honeybees are certainly adept at living out into the wild. The picture on the left-hand side, in the more temperate parts of the world, honeybees can just live out in the open without any protection at all. This is a long cascading comb with honeybees on the inside. Picture on the right-hand side is from the Garden of the Gods, if you ever get a chance to go. You're looking sort of up underneath a rock crevice, and you can kind of make out within this rock crevice a massive, massive set of comb that honeybees can live in. So even in Colorado, honeybees can survive with very minimal protection, just maybe protection from rain, typically is the number one thing they're looking for protection from. Has anyone ever seen a bee tree before? In other words, a hollow tree with bees living in it? That's really cool to find one of those. I know there's a couple over in Schlitz Audubon, as I understand. We had bee trees on our farm growing up as a kid, and I always kind of knew where to go find them, but certain trees, if they're struck by lightning or just through their own growth cycle, will end up hollowing out, and that's a great cavity for honeybees to live in. You'll often find those in Wisconsin. That's what you'll often see is just a big cluster of bees sort of on the side of the tree. You may see a couple flying in and out, but largely you'll just see a collection. So again, when people find out that you're becoming a beekeeper, they may start telling you about these kind of things. Oh, you should see this at my house. It's very cool. Check it out. Here's a cross section. So here's a gentleman that's kind of cut down a tree, and you sort of see, drop this line on. You kind of see what looks to be a set of comb on the inside. There we go, that's much better. On the inside of a tree, here on the left-hand picture. So, in other words, the honeybees have made these combs inside trees. And so, honeybees really can make do anywhere. It's a classic example of Perth, Australia. There's a compost bin, and then they took the lid off this compost bin, and there's some honeybees. And these honeybees have made their comb on the underside of this compost bin. A couple of things to realize. Number one, notice the color, bright white. Fresh wax is bright white. You've never seen it before. It's bright white, and notice that it's all kind of interestingly parallel to each other. Kind of third fascinating thing is to think that it's parallel to each other, and all this construction is happening in the dark. Every year I think about this, and I think how fascinating it is these insects can become so organized that they can do this construction and do it in the dark.
What are the chances that you start a hive in your yard and the bees migrate to a tree, a compost bin, the side of your house, your garage?
Well, I think that's a great question. And it's not that they would migrate. The bees that you start wouldn't leave. It's that they would swarm. And swarming is sort of leading into this point. And I think this is where beekeepers have to kind of realize that your next door neighbor doesn't want this happening at their house. And here's a picture. These are floor joists, and you can see where I'm guessing the bees must have somehow gotten through some siding and built a fairly substantial hive within the floor joists of someone's house. So what are the chances of swarming? Well, pretty good. They're going to swarm. And I'll show you some techniques to kind of prevent that. That'll be a big part of our discussion next February, is how to prevent swarming. But you certainly don't want to encourage it. You can do your best to not have it happen. Now, the chances are, if they swarm, they're going to go way out into the world, and they're going to try to find something other than your house. The probability of you having your bees in your basement are fairly slim, but it's certainly out there. I think that's kind of why a lot of the bans in municipal governments have happened. I just want to go back to this idea, though. We obviously don't want honeybees living in soffits and in places in our houses, but they've really been part of our history for quite some time. I mean, dating back even to the Egyptians, keeping honeybees in clay pots. We've got then sort of the kind of original crude-looking box-like structures that bees would sort of be put in, followed by these ultra-elaborate Victorian-style cabinets that bees were kept in, and then kind of the classic skep that was really popular in the United States, really across the world for quite some time. Now, one of the takeaway messages, with the exception of the one on the bottom right-hand corner, which is just wacky, largely, the way that these bees were kept is that the bees were sort of just put into these objects, be that clay pots or skeps. And in order for the beekeeper to get the honey out, they would have to literally tear it apart. It would kill the bees, and every year they would have to put new bees into the clay pots, skeps, or these kind of crudish wooden boxes. And so, around the mid to late 1800s, you had this kind of resurgence. So, the North American Beekeeping Association is a picture from 1896. Beekeeping kind of started getting organized, and beekeepers started playing around with more uniform ways to keep bees and looking at the biology of the honeybee and trying to figure out how do we sort of work with this insect. What I think is really super cool as an entomologist, to take a look at this photograph in the top left hand, again from about the same era, and then just sort of let your eyes gaze across this picture on the right hand side, 1896. The role of women in beekeeping. It's 1896. The 1, 2, 3, 4, you can kind of count the number of hats. These are active beekeepers. So beekeeping is something that wasn't just for the guys to do. It has a long history of women being involved, which is fantastic, in my opinion. Really great contributions. So we started keeping bees in constructed hives. And these are hives that can be as crude as split logs. These hives are typically kept more in African areas, places where you have concerns about predation into your honeybees. They're often kept in just a log that's been split open, and the bees themselves will build out the comb. Here's a picture of, bottom left-hand corner, a weaved basket. Again, this is sort of very similar to the way that bees were kept in the United States in skeps. And then you kind of jump into the concept of what we see today, which are these white boxes stacked on top of each other with these frames inside. And they can be white, or they can be as elaborate as this beekeepers who are painting theirs. And you can imagine this kind of looks like a house that's stacked on top of one another. And largely, this concept of movable frames is owed in large part to Reverend Langstraw. So these pictures on the left-hand side, if you ever make it to Philadelphia, you can walk over to his birthplace. There's a historic marker there. This is kind of arbitrary on the side of the road, but it's there, and that's where he made some really great discoveries. And he sort of patiently started observing bees, and again, bees being kept in sort of rudimentary things. And what he started noticing, if you kind of pay really close attention to the way that this design works, is that all the combs are parallel to each other. And his greatest contribution was that he figured out that the bees maintained a particular amount of distance between one comb and the next comb, between this comb and this comb, between this comb and this comb, between this comb and that comb. And he referred to that as bee space. And he said, you know, what I could do is if I constructed a hive, and I used frames, and I kept these frames a certain distance apart, then I don't have to destroy the entire colony when I'm ready to harvest my honey. And that's the concept of movable frames. And so that's the way that bees have been kept largely since the late 1800s after he sort of made this large discovery. And which is one of the reasons why, this is a picture on the right-hand side, with these movable frames, we can manipulate the way the hive operates to kind of maximize either its production, maximize its health, diagnose any sort of maladies that may happen. And so you can end up in these kind of scenarios where you've got a beekeeper climbed up on a ladder, he's got, I don't know, a dozen or so honey super stacked one on top of the other, and he's making just copious amounts of honey. And that was largely due to this concept of movable frames. Years ago, I had a question about, well, why white hives? And I think it goes back to the history of people painting their houses white, so they had some white paint, so why not paint the hives white? There's